Good day, guys. This is Mr. Prince Maths and Science class, and in this video, I'm gonna be talking about kinematics in 2 dimension. In the previous video, I talked about kinematics in 1 dimension. So, in the video before, kinematics in 1 dimension talked about the kinematic equations, right? So, in this topic, we are going to be dealing with all the kinematic equations, but we are going to be having an x and y component of it. That is why it's called kinematics in 2 dimension. So the first example we have here says an aircraft pictured below has an initial velocity component of ux equals plus 22 meter per second and an acceleration component of ax equals plus 24 meter per second squared. In the y direction, we have uy equals to plus 14 meter per second and ay equals plus 12 meter per second squared. At a time of t 7 seconds, they find the x and y component of the spacecraft's displacement. So this is the spacecraft, this is the picture of the spacecraft, okay? So this is what we have right here. So this is it, the direction of the spacecraft in the y component and in x component, okay? So the first thing I'm going to do is I'm going to collect all the data for the x direction, okay, for the direction in the x component. So what I'm going to do is we are finding the distance, the displacement in x and y component. So for the displacement in x component, we don't have it, we are not given, okay, but we are given the acceleration in x component to be plus 24 meter per second squared, okay. The final velocity for the x component is not given, okay, and then we have the initial velocity for the x component to be 22 meter per second, okay. Also, we have that the time given is 7 seconds. So when you look at the parameters given, we have ax, ux, okay, and time, and we have to find displacement. The right formula, the proper kinetic equation formula that is needed is s equals ut plus half at squared, okay. So that will be x equals to u x t plus 1 over 2 ax t squared. So the initial velocity in the x component is 22 times the time is 7 seconds plus 1 over 2 times 24 times 7 squared, okay. So 24 divided by 2 will give us 12, okay. 22 times 7 is 154, okay, and then we have 12 times 49. 12 times 49 will give us 5 plus 588, not times, sorry, plus 588. So when you add it up together, you get 740 meters. So that's the displacement, the spacecraft displacement in the x direction. And so we have to collect data to find the displacement in the y direction. Collect y direction data. So in this case, we don't also know the displacement is not given, okay. That's what we are looking for. So the acceleration in the y component is 12 meter per second squared. The velocity in y direction is not given, okay, and then uy is 14 meter per second, like we are given in the question, and it's also in the same time. The same time is 7 seconds, okay. So we are still going to use the same formula. So that will be s equals to uyt plus 1 over 2 ayt squared, okay. So uy is 14 times 7 plus 1 over 2. Acceleration in y direction is 12 times 7 squared, okay. So 12 divided by 2 will give us 6, okay. So 14 times 7 will give us 98, So we have 98 plus 6 times 49. 6 times 49, that's 294. Okay, so the total we should get is 390 meters. Okay, that's 390 meters. So therefore we can see that after 7 seconds the spacecraft is 740 meters to the right and 390 meters above the origin. So therefore after 7 seconds the spacecraft is 740 meters to the right, okay, and 390 meters above the origin. So we have the next question. So the next question is a continuation from question 1. So now it says from the question 1, we are given that the x components of the spacecraft initial velocity and acceleration are respectively ux equals 15 meters per second and ax equals 19 meters per second squared. It says the corresponding y components are uy equals plus 9 meters per second and ay equals 13 meters per second squared. It says at a time of t equals 5.3 seconds, find the spacecraft's final velocity. So when we are finding the final velocity, we are going to find the magnitude and the direction. So now let's write out all the parameters, okay? So we know that ax is equals to 19 meters per second squared. Ux is equals 15 meters per second, okay? We have uy to be equals 9 plus 9 meters per second. We have ay to be equals 13 meters per second squared, okay, and we have the time is at the time of 5.3 seconds. T will be equals 5.3 seconds, okay. So now we are going to find the final velocity. This is what we are looking for, okay, right? And we are going to find, that means we are going to find the final velocity in meters per second square and the angle, that's the direction, okay. That, so we are going to find theta too. So we need to note that the final velocity the final velocity has the component in y component and the x component. So we know that final velocity is a vector quantity, right? So the vx and vy is going to form a right angle triangle. So now we can say that by Pythagoras theorem, we have it that v is equals to vx squared plus vy squared, okay. So now in this, and we know that theta, to find the angle, will be arctan. So you need to know this if you don't know it before, vy over vx, okay. So now let's find the s component first. So since we are given ax, ux, and the time, the proper formula to use will be v equals to u plus at, okay. So that will be vx is equals to ux plus axt, sorry. So that will be equals to vx is equals to 15 plus 19 times 5.3, okay. So if we multiply that together, we should get 115.7 meters per second, okay. So now let's find the y component. So vy will be equals to uy plus ayt, okay. So vy will be equals to 9 plus 13 times 5.3. So if we add and multiply together, we should get 77.9 meters per second, okay. So now we have v now will be equals to I said vy squared plus vx squared, or vx squared plus vy squared, whatever order. So that'll be 115.7 squared plus 77.9 squared. So when we do that together, we should get the square root of 19,454.9, okay. So when we get that, we should get find the square root of that, that will be 139.48 meter per second. Okay, so that's approximately 140 meter per second. So now we want to find the direction. Now to find the direction, we are going to use the formula tan is equals to Vy divided by Vx. So we have tan theta is equals to Vy over Vx. So that's 77.9 divided by 115.7. So let's point that in the calculator. 77.9 divided by 115.7 should give us 0.6733. So that will be arctan. Sorry. That will be theta is equals to arctan 0.6733. Okay. So that will be equals to 33.95 degrees. That will be approximately 34 degrees. Okay. So we can say that after 5.3 seconds, the spacecraft has a velocity of 140 meters per second in a direction of 34 degrees above the positive x-axis. So now we have a question in another dimension. Okay. So this is like an object that is moving at different velocities. I mean different velocity, yes, with the band and at different angles. So I'm still going to do more examples of this in another video. So now I'm going to write it in an x component and y component. So the way I'm going to explain this is going to be quite different. It's very easy, but it's going to be quite different from what I've been explaining earlier. Okay, so the x component will stand for cos theta, okay, and the y component will stand for sine theta. So let's get it clear like that. So now let's start with 5 meters per second squared. Let's start with this one first. So we start with that one. Now the angle. Now I want to do it in the x component. The angle between this side and this side is 90 degrees. Okay, that's 90 degrees. So we are always looking for the angle that is connecting the line we're talking about and the line on the x direction on the horizontal part. So the angle between this and this is 90 degrees. Okay, so that will be 5 cos 90. Okay, and 5 cos 90 will give us 0. X for the y component. Now this angle, the way it's facing up, I want to clean this one. This angle, the way it's facing up, is not because now we're looking at it at the y component. This angle is at a 0 degree. Okay, it's on a straight line. It's on a straight line path. That is 0 degree. Okay, so that will be 5 sine 0 degrees. Okay, so that will give us 0 also. So now let's go to the next one. We have 12. So we have 12. Now I told you that for the x component, you do the angle that is when you calculate the angle, it must be the angle that is on facing the horizontal part like this. So from here to here is 52 degrees. So we're going to just use the 52 degrees like that. So that will be 12 cos 52. That will give us 7.39. Okay. So now if we do for the y component, that will be 12 sine 52 degrees. Okay, and it is positive in this case because it is up and it is facing towards the right. So that is why we are still putting on positive. 12 times 52 degrees will give us 9.46. Okay, so now we have 8 now. Now this one is on the x component, so it's directly facing this side. It does not have any angle. It's just going on a straight line. So that will be angle 0 degrees. Okay. So that will be 8 cos 0 degree will be equals to 8 because cos 0 is 1. And then we have 8 sine 90 degrees. Okay. Because when you look at the angle from this horizontal part, where you want to look at it in a vertical part, right? So yeah, it has to be this one connected to this part. So that will be 90 degrees. Okay. So in that case, that will be 8 sine 90 will be equals to 8 also. So now let's go to 7 now. So 7 now, this one is facing down, but it is facing right. Okay. It's facing down, but it is facing right. So for the x component, because it is facing towards the right part, it's still going to be positive. Okay. So that will be 7. But now this is going to be this angle that is facing this side. Since this side is 45, so 90 minus 45 is 45. So that will be 7 cos 45 degrees. So that will give us 4.95. Okay. So now we have, because now it's facing down, for the y component, this is going to be negative. So this will be negative 7 sine 45. Okay. So negative 7 sine 45 will be equals to negative 4.95. Okay. So now the last one is 5.5 now. So for 5.5, we can see that 5.5 is facing towards the left. Yeah, it's facing towards the left here, this side. So that will be negative. This is a negative x-axis. This is positive x-axis. This is negative y-axis. This is positive y-axis. So that's how you able to take note if it is negative or positive. So this is negative 5.5 cos. Now the angle between this place and this place will be 90 minus 65. That will be 25 degrees. So I always thought that is the angle that is facing towards this side. That will be the angles that you use, the closest. So that will be minus 5.5 cos 25 degrees will give us minus 4.98. Okay. And then we have 5.5. This one will be positive because it's facing up. Okay. 5.5 sine 65 degrees will give us 2.32. Okay. So if we add it up, so this will be 15.36 meter per second. And if we add this one up, then we should get about 14.83 meter per second. Okay. So now if we want to find the final velocity now. So the final velocity will be v is equals to vx squared plus vy squared. So that will be equals to 15.36 squared plus 14.83 squared. So if you do that, that will be v equals to the square root of 455.859. Okay. So if you find the square root, that will be 21.35 meter per second. Okay, so that's the magnitude. So now I want us to find the direction. So that will be tan theta is equals to vy over vx, not vy over vx. So that will be equals to 14.83 meter per second divided by 15.36 meter per second. So that will be 0.9655. So we do theta is equals to arc tan 0.9655. That will give us 43.99 degrees. Okay, so that will be approximately 44 degrees. So that will be all for this video. I'll probably still do more of this type of question maybe in another video. And I hope you enjoyed the video. Make sure you like, share, and make sure you subscribe to the channel. Thank you and peace out.